everyone, a warm welcome to the fifth part of line integral.
Complex definite integrals are called line integrals. They are denoted by integral over c f of z dz. Here the integrand fz is integrated over a curve c or through a portion of c. Really these integrals are complex integrals in terms of real definite integrals. So we can evaluate these types of integrals by converting into real definite integrals. In our problem, C may be straight lines, triangle, square, rectangle, parabola or a part of a parabola, circle or a portion of a circle. Also at times C is given by its parameter representations.
In this video, I am going to illustrate evaluation along circles. If C is mod z equal to 1, then on C we must know z equal to e raised to I theta, where theta varies from 0 to 2 pi, dz is I e raised to I theta d theta. If C is mod z equal to r, then z equal to r e raised to I theta. Here also theta varies from 0 to 2 pi. And again dz is I into r into e raised to I theta d theta. Usually in our problem, C is the unit circle. Let me illustrate it.
Evaluate integral over C set conjugate dz, where C is the unit circle. See, in the case of circles, you have to remember this result. If mod z equal to r, then z is r e raised to I theta. In most of our problems, our circle may be the unit circle, mod z equal to 1. See here, we have to integrate z conjugate along the unit circle. See, in the case of circles, first you express its polar form. See, mod z equal to 1 implies z equal to e raised to I theta. And the theta varies from 0 to 2 pi. You have to remember this result. Next you write what is dz. See, z equal to e raised to I theta. So what is dz? It is I e raised to I theta d theta. Next we consider the integral over c z conjugate dz, which is equal to, see, for evaluating this integral, really z is x plus I y. See, in this we have two variables. So you can evaluate such integrals by converting the integrand into a single variable. That's our aim. So in the case of circles, if you make these substitutions, you can change this complex integral into a single variable real integral. So what is z conjugate? Z is e raised to I theta. So what is z conjugate? Z equal to e raised to I theta. Conjugate is obtained by just replacing I by minus I. So Z conjugate is e raised to minus I theta. Dz is I e raised to I theta d theta. Now it is completely in terms of theta. We have to integrate with respect to theta. So you put the limits for theta. What is theta? Theta varies from 0 to 2 pi. Next you integrate this. This will cancel. And I is a constant, so I into integral 0 to 2 pi d theta. That is integral d theta, it is theta from 0 to 2 pi. You apply the upper limit and lower limit, you can see the answer is 2 pi. Next question, evaluate integral over c, z minus z square dz, where c is the upper half of the unit circle. See, we have to integrate along the part of the unit circle. Okay. See, the circle is mod z equal to 1. So what is z? E raised to I theta. So dz I e raised to I theta d theta. Here, theta varies from what to where? See, we have to integrate z minus z square through the upper half of the unit circle. See, this is our complete unit circle. We have to integrate from here to here only. So the theta variation is 0 to pi. Next you consider the integral over c z minus z square dz, which is, what is z? E raised to I theta minus, what is z square? E raised to I theta the whole square. Dz is I e raised to I theta d theta. Theta varies from 0 to 2 pi because we have to only integrate from the upper half of the circle. We are integrating along a semicircle which lies in the upper half of the plane. That's why it is 0 to pi. and integral 0 to pi. Here I is a constant, you take it outside. It is e raised to I theta minus e raised to 2I theta into e raised to I theta d theta. That is I into integral 0 to pi e raised to 2I theta minus e raised to 3I theta d theta. Next we have to integrate. That is integral e raised to I theta. See, integral e raised to ax is e raised to ax by e. So its integral is e raised to 2I theta by 2I minus e raised to 3I theta by 3I from 0 to pi. So I into e raised to 2I pi by 2I minus e raised to 3I pi by 3I minus, when theta is 0, e raised to 0 is 1. So it is 1 by 2I minus 1 by 3I. You have to remember here we have non-zero lower limits. That is I into, that is e raised to 2I pi. See, here you have to apply e raised to I theta is cos theta plus psi sin theta. So e raised to 2I pi is cos 2 pi plus I sin 2 pi. It is 1 minus e raised to 3I pi. E raised to 3I pi is cos 3 pi plus I sin 3 pi. See, cos 3 pi. 3 pi is minus 1 plus I into 0 is minus 1. So plus 1 by 3I. Next minus 1 by 2I plus 1 by 3I. You can see this will cancel each other. That is I into 2 by 3I. So the answer is 2 by 3. Next we have to answer another interesting question. Integral over C, mod z dz. Where C is the left half of the unit circle, mod z equal to 1 from z equal to minus I to z equal to plus I. See here, what is C? C is the part of the unit circle. See, we have the unit circle. See, we have to integrate mod z in the left half of the unit circle. See, this is its right half and this is its left half. We have to integrate along the left half of the unit circle. From where to where? It is given from minus I to I. Where is minus I? Minus I is the point 0 minus 1 and I is the point 0 1. So it is, its radius is 1, so it is minus I and see this is I. See, here we have to integrate from minus I to I. Here direction is given like this. So our integration part is, we have to integrate mod z from minus I to I, where this curve is the part of the unit circle. So here mod z equal to 1. So what is z? E raised to I theta. And theta varies from, here we have to integrate from minus I to I. So this is 0, pi by 2, pi, 3 pi by 2. So here it is pi. So theta varies from 3 pi by 2 to pi by 2. If we have to evaluate from I to minus I, then theta varies from pi by 2 to 3 pi by 2. Since in the question it is given that it is from minus I to I, so we have to take theta 3 pi by 2 to pi by 2. That is dz I e raised to I theta d theta. Now consider the integral. Integral over C mod z dz, which is, what is mod z? Modulus of z. See, mod z is 1. Or you take its modulus, you can see it is 1. So 1 into dz. Dz, what is dz? Dz is, see, integral 1 into dz is I e raised to I theta d theta. That is integral I e raised to I theta d theta. What is the limit for theta? It is from 3 pi by 2 to pi by 2. So 3 pi by 2 to pi by 2. And it is I e raised to I theta by I from 3 pi by 2 to pi by 2. I will cancel. It is e raised to I theta from 3 pi by 2 to pi by 2. Next we have to put the limits. You can see it is e raised to I pi by 2 minus e raised to I 3 pi by 2. That is e raised to I pi by 2. You apply the result. E raised to I theta is plus I sin theta. So what is e raised to I pi by 2? Cos pi by 2 plus I sin pi by 2. This is 0 and this is 1. So you can see it is I. What is sin 3 pi by 2? Cos 3 pi by 2 plus I sin 3 pi by 2. What is cos 3 pi by 2? It is 0. Sin 3 pi by 2 is minus 1. So it is minus I. So here I minus minus I. It is 2I. So our integral over C mod is a dz is 2I. Next we have to answer another interesting question. The question is, show that integral over C dz by z equal to minus I pi or I pi. According as C is the semicircular arc, mod is equal to 1 above or below the real axis. First you notice what is C. Here you consider a unit circle. See, you evaluate first along the semicircular arc above the real axis. See, this is our real axis. This is our real axis. See, the semicircular arc above the real axis is this part of the unit circle. This part of the unit circle. So you consider the first case as we have to evaluate integral over C dz by z. The first part is above the real axis. So the upper half of the unit circle. That is, it is a semi-circle in the upper half of the circle. See it varies from 1 to minus 1. That is from 0 to pi. So you consider the first one as above the real axis. So what is C? C is mod z equal to 1. That is z equal to e raised to I theta. Here theta varies only from 0 to pi. What is dz? I e raised to I theta. Next, what is integral over C dz by z? That is integral dz is I e raised to I theta by z is e raised to I theta. So it's dz is I e raised to I theta d theta. So it is d theta. And theta varies from 0 to pi. You can see this will cancel each other. So I will integrate 0 to pi d theta. And it is I into theta from 0 to pi. So it is I pi. So integral over C dz by z is I pi. If you consider the part of the unit circle in the upper half of the real axis. So the answer is I pi. See here the question is show that. See, show that the answer is minus I pi for above the real axis. So for the above the real axis we have to prove the answer is minus I pi. And for below the real axis we have to prove it is I pi. Here we got the answer as I pi. There is a small sign difference. Here we consider the curve as a semicircular arc in the above the real axis. See, above the real axis this. Here the direction is not mentioned. So if the direction is not mentioned, you take it as positive direction, and positive direction is considered as an anti-clockwise direction. That's why here we consider it as like this. So integral 0 to 2 pi. But here we have to prove it is minus I pi. So you consider, see in this question, you have to consider the direction as, if the direction is not mentioned, you have to take it as anti-clockwise direction. Here, the question is show that for getting the answer, you have to choose the direction properly. So here we got the answer as I pi. So for getting minus I pi, we have to integrate from pi to 0. When you interchange this limit, there will be a negative sign. So we have to interchange. So you take the direction as like this. That is pi to 0. So in the first part, you have to take it as pi to 0. Pi to 0. So you put pi to 0. You can see the answer is minus I pi. Really, in this question, it must be I pi. But here, unfortunately, the question is showed that the answer is minus I pi. That's why I changed the direction. Next, we have to consider C as a semicircular arc below the real axis. So, our C is only this much. And we consider positive direction as anti-clockwise direction. Here, direction is not mentioned, so we consider it as anti-clockwise direction. That's why in the first part we consider it as like this. That's why it is from 0 to pi. Here, we have to evaluate this integral. But this is set e raised to I theta. Dz is e raised to I theta into I d theta. Here, theta varies from what to where? Theta varies from pi to 2 pi. Pi to 2 pi, not a 0. See, from 0 here it is pi to 2 pi. So, variation is pi to 2 pi. Now, consider integral over C dz by z. It is integral I e raised to I theta d theta by e raised to I theta pi to 2 pi. So, it is integral pi to 2 pi I d theta. That is I into theta from pi to 2 pi. So, it is I into 2 pi minus pi. It is I pi. Let me evaluate another interesting question. Integral over C log z dz where C is mod z equal to 1. Here mod z equal to 1. So z is e raised to I theta and dz is I e raised to I theta. See, integration is over the unit circle. So theta varies from 0 to 2 pi. Next to consider the integral. Integral over C log z dz. This is log. This is set e raised to I theta. Then you put is dz. It is I e raised to I theta d theta. Theta varies from where to where? It is from 0 to 2 pi. What is log e raised to I theta? It is I theta into I into e raised to I theta d theta. I into I square it is minus 1. So minus integral 0 to 2 pi. Theta e raised to I theta d theta. See here the integration with respect to theta. See the integrand is a product. So you can integrate directly by applying integration by parts. Here, let me integrate through a shortcut method. See the shortcut method is, you start with the theta. You assign alternate plus and minus sign. Starting with the plus sign. Here plus minus etc. Next you write its derivative. Derivative of theta is 1. Next you consider the second term, that is e raised to I theta. You write its integral here, e raised to I theta by I. Next you write its integral here, that is e raised to I theta by I square. See now integration is over. Next for applying the lower and upper limits, you simplify these signs, you make some simplifications, that is minus theta into e raised to I theta by I square is minus plus e raised to I theta from 0 to 2 pi. That is minus 2 pi e raised to I 2 pi by I plus e raised to I 2 pi minus, when theta is 0, 0 into this quantity it will be 0 plus e raised to 0 it is 1. It is minus 2 pi. What is e raised to I 2 pi? It is cos 2 pi plus I sin 2 pi. It is 1. So it is 1. E raised to I 2 pi is 1. This will cancel. So the answer is minus 2 pi by I. 1 by I is minus I. So as you can see it is 2 pi I.